straight line. So in the straight line, first point is this. On a two-dimensional or this two-dimensional is called as Euclidean, EUCLIDN, mathematician name. On a two-dimensional or Euclidean plane, okay, any point can be represented. Any point can be represented by a pair of real numbers. Pair of real numbers using two non-parallel straight lines. So the point where these two non-parallel reference lines meet is termed as the origin of the reference axis. So by convention, one axis is called the x-axis and one y-axis. So this is the first point. So any point on the plane now can be determined with reference axis. Like the meaning of this point is, suppose on a plane, this plane is called as a Euclidean plane or two-dimensional plane. On a plane, so this is one line and this one is another line. Actually, this is another line. So these two are non-parallel lines. So these two lines meet at a point. So this point is called as origin. This point is called as origin. And from these two lines, one line is called as x-axis by convention, another line is called as y-axis. So this is x-axis. By convention, this is called as x-axis and this line is called as y-axis. This is y-axis. So now how to locate this is the Euclidean plane. We have taken the two reference lines, that is x-axis and y-axis. Now here, suppose the point P lies x units along the x-axis. Suppose second point, the point P lies x units along point P lies x units along x-axis and y units along y-axis. Therefore, then P can be represented by point P can be represented by x comma y. Here x comma y belongs to real numbers. So here x is called abscissa. ABSCISSA, abscissa of P. Y is called ordinate of P. So here x is called as abscissa, or you can call this as x coordinate also. X coordinate of P. So this ordinate is called as y coordinate. So x coordinate means abscissa, y coordinate means ordinate, and x comma y together are called as the coordinates of P. X comma y together are called the coordinates of P. So this is the second point. Means, see, if you take the same diagram here, copy this. So here, on the second point, suppose on x-axis, suppose this distance you take, this distance is x-axis, and this distance is suppose y-axis. Sorry, this distance is x units, this distance is y units. You join these two lines, then this point is called as what? X comma y. So that is, this is px comma, suppose this is px comma y means, so you draw one line parallel to this y-axis. Yes or no? So this distance is this y coordinate, and you draw one parallel line parallel to x-axis. So this distance, yes sir, this distance is x. Yes sir, not exact diagram, it's parallel. So this is x. So this is x. So this is also x. So this distance is, so this distance is x coordinate, and this distance is y coordinate. So actually here angle between the coordinate axis, is some theta. So, but for convenience, generally we will take the coordinate axis, the coordinate axis in such a way that the angle between x and y axis is 90 degrees. Yes, or no? You can take theta also. Generally, theta is also okay. Theta, you can take any angle. You can take the reference frame as we wish according to our requirement. So no, here the angle between the x and y axis is what? Theta. They're not 90 degrees. But generally, throughout our mathematics, yes or no, we will take the coordinate angle between the x and y axis 90 degrees. That is called as the rectangular coordinate system. Rectangular, that 90 degrees, the angle between the x and y axis is 90 degrees, then that is called as a rectangular coordinate system. So in almost all the cases, in our level, we will use that rectangular coordinate system. So actually we'll take this one. So in general, this is y-axis and this is x-axis. Generally we use this one. So here this is x-axis, this is origin, this is y-axis. Yes or no? So here angle is what? 90 degrees. మనం ఇది మాత్రమే వాడతాం. సో ఏదైనా తీసుకోవచ్చు యాంగిల్ అదర్ దాన్ 90 degrees కూడా తీసుకోవచ్చు. So suppose the point px, the meaning of this one is what? Just you drop the perpendicular on x-axis and drop the perpendicular on y-axis. So suppose this is the foot of the perpendicular and here, this is the foot of the perpendicular. Then this distance represent this x and this distance represent this y. So that is the meaning of the point, the location of the point or position of the point. So this distance is x. So this distance is y. That's why this distance is y. Or this same, this distance is also x. Yes or no? So this is the location of the point. Clear? This result number 1. Result number 1. In result number 1, first one is distance formula. So distance formula. So distance formula means suppose on a plane the 2 points are given. Suppose so the distance between 2 points, distance between 2 given points, distance between 2 given points, px1 comma y1 and qx2 comma y2. So distance between these 2 points. Already we have seen the position of it from the position of the point concept. So we take any 2 points on a plane. I will take in first quadrant. So this is x-axis, y-axis. You can take the 2 points anywhere. You can take both the points in first quadrant, or one is first quadrant, another in second quadrant, like that. You can take in any way. But I will take in 2 points in first quadrant only. So suppose this is the point px1 comma y1. So the meaning of this one is what? If you drop the perpendicular on x-axis and y-axis, so this angle is 90 degrees. Therefore this is origin. This distance is x1. Suppose this is m1 and this is n1, and this distance is y1, or this distance is y1. Next you take another point, that is qx2 y2. So what is the meaning of this one? You drop the perpendicular. This is m2. Then you drop the perpendicular. This is n2. So now this distance is equal to what? This total distance is now this total distance is equal to what here? X2. Yes or no? Now this total distance is equals to what? Y2. So means this total distance represented by this x2. This total distance is represented by this y2. Now our job is what? To find the distance between these 2 points. Yes or no? Now the distance between these 2 points is the question. So to find the distance between these 2 points, what I do is I will drop one perpendicular from px1y1 on this line, that is qm2 line. The job is to find the distance between this px1y1 and qx2y2. So for that one, what I have done, I dropped the perpendicular from px1y1 and this on this qm2 line. So let this foot of the perpendicular is r. Yes sir, the foot of the perpendicular is r. Now tell me, now we need to find this distance, pq distance. Now what is this OM1 distance is, see this one, OM2 distance is x2, OM1 distance is x1. What is M1 M2 distance?
x2 minus x1.
X2 minus x1. This distance is x2 minus x1. So therefore this distance is also what? X2 minus x1. This PR distance. In the similar manner, so this distance ON2 distance is y2, ON1 distance is y1. Therefore N1 N2 distance is what? Y2 minus y1. Therefore QR distance is y2 minus y1. So this distance is y2 minus y1. That is n1 into distance is y2 minus y1. Therefore, QR is same length as n1 into. Therefore, QR distance is also equal to y2 minus y1. It's a right angle triangle. Now our job is to find the distance between PQ. So for this right triangle, use Pythagoras theorem. Okay. So from right angle triangle PQR. From right angle triangle PQR, if you use the Pythagoras theorem, then what you get? PQ square, hypotenuse square is equals to, so adjacent square, that is PR square, plus opposite side square, that is QR square. So our requirement is PQ. Therefore, PQ square is equals to, PR is what? X2 minus X1. This is X2 minus X1 whole square, plus what is QR? Y2 minus Y1 whole square. Y2 minus Y1 whole square. So now our job is PQ distance. Therefore, PQ is equal to what? Square root of X2 minus X1 whole square plus Y2 minus Y1 whole square. Actually, in general, see, Y2 minus Y1 whole square. In general, what we do, if you have x square is equal to alpha, then x equal to, you will take plus or minus alpha, square root alpha. But here, don't take plus or minus. Why? Distance never be negative. Okay. So root of anything is always positive. Distance never be negative. Therefore, PQ distance is what? Just with positive sign. Therefore, x2 minus x1 whole square plus y2 minus y1 whole square, square root. So to find the distance between the 2 points, x1 and x2 y2, just what you do? Square root of difference of the abscissas or x coordinates whole square plus difference of the ordinates, that is y coordinates whole square, square root. Okay. Find the distance between the points A 2, 4, B minus 3, 6. So this is the question. So solution, directly we will use the formula, that is x1 y1 and x2 y2. So AB distance is equals to what? Square root of x2 minus x1 whole square. Therefore, minus 3 minus 2 whole square plus y2 minus y1 whole square. Therefore, 6 minus 4 whole square. So that is equal to minus 3 minus 2 minus 5 whole square plus 6 minus 2, 2 whole square. That is equals to, this is minus 5 square, 25 plus 4. That is equals to a root 29 units. So this is the answer. Question number 2. Find the distance between the points P A cos theta, A sin theta, and O 0, 0. Distance in the A cos theta and A sin theta and origin. So that is solution. So this is x1 y1 y2. So PO distance is equals to square root of x2 minus x1 whole square, 0 minus A cos theta whole square plus 0 minus A sin theta whole square. That is equal to square root of, this is A square cos square theta plus A square sin square theta. So this is equals to, you take out A square common, A square into cos square theta plus sin square theta. That is square root of A square, because cos square theta plus sin square theta is 1. Now tell me, what is this? Under root of A square is what?
A.
No, mod A. Okay, the distance never be, it is under root of, see, under root of x square is not equal to plus or minus x, so no. But under root of x square is equal to what? Mod x. Under root of anything is always positive, mod x. So this is the distance between 2 points, between the points P A T1 square comma 2A T1 and Q A T2 square A T2. So this is the question. So find the distance between the points. Find the distance between the points P A1 square 281 Q A2 square 282. So this is the question. Solution. So x1 y1 x2 y2 are the points. So distance between 2 points is equal to square root of x2 minus x1 whole square, that is at2 square minus at1 square whole square plus 2at2 minus 2at1 whole square. Now this is equal to square root of, here if we take out a common, then you will have outside a square or not. You take out a common. If you take out a common, you will, a will be outside with power 2. Yes or no? Therefore, this is a square into t2 square minus t1 square whole square. Similarly, if you take out here 2a common, therefore 2a comes with power 2 outside. That's why that is 4a square into t2 minus t1 whole square. T2 minus t1 whole square. So now this is equal. Now from these two terms, you take out a square common. So this is equal to a square into t2 square minus t1 square whole square plus 4 times t2 minus t1 whole square. So if you take out this a square outside, then you will have mod a into square root of this. Now this, now this one, this t2 square minus t1 square can be written as t2 plus t1 into t2 minus t1, a square minus b square form. So this is t2 plus t1 whole square, t2 minus t1 whole square. So plus 4 into, this is t2 minus t1 whole square. Now this is equal to mod a into square root of, from these two terms, this t2 minus t1 whole square common. Yes or no? So this term is common. Then what you get, this is equal to t2 minus t1 whole square, you take out common. Inside the bracket, you left with t2 plus t1 whole square plus 4. Now again you take out this t2 minus t1 whole square common. It's a perfect square. Outside, sorry, outside the square root. Then what you get? This is mod a into mod t2 minus t1 into square root of t2 plus t1 whole square plus 4. Okay, this is the answer. So the distance depends on the value of a and t1